Welcome to part 2 in our video lecture on ecosystem ecology. In this video lecture, we're going to go over food webs and food chains. We'll discuss ecosystem productivity, net primary productivity, and gross primary productivity, and we'll have a discussion on trophic pyramids. Let's talk about food chains. Remember this one, the energy available from the kelp is passed on to the urchin, which in turn is passed on to the otter. The arrow in between these organisms represents the flow of both energy and matter from one organism to the next. Here's another one. The food wheat, the energy available in the food wheat is passed on to a cow. That cow is then eaten by the human. In reality, our food chains can become a little bit more complex when we think about more than one relationship, right? Think about it. It's not so linear. Humans, in addition to eating the cows, can also transfer directly from the wheat into their stomachs and use that to continue to live. So our food chains begin to start to resemble food webs. Take a look at this food web that we saw in part 1. Notice how at the very bottom of the picture here, that green dot represents the grasses. And notice how all of the arrows radiate out from it. All of the energy in this specific ecosystem comes ultimately from the producers in the area, which in turn comes from the sun. So let's talk about productivity. Many factors determine the number of organisms in an area. Think of the keystone species, or think about even the amount of space available to grow and live. But overall, the total net energy available in an ecosystem comes from that ecosystem's plants, the producers. Take a look at the sun. This leaf and the algae in this pond will undergo photosynthesis because of the solar energy irradiating out of that sun. But the plants aren't 100% efficient at making food. In fact, plants are only able to convert about 1% of the total solar energy hitting the earth. The rest of that energy is lost as heat to the atmosphere. And photosynthesis itself is not very efficient. In fact, the reason why plants are green is because they reflect rather than absorb green light. If they absorbed it, they would be using the entire visible spectrum of light rather than reflecting some of it. So the total measure of photosynthesis in an area is called the gross primary productivity. Let's talk a little bit about the word gross. Take a look. This is not my paycheck. Oh my gosh. Well, look at that pay rate. $16.75 an hour, 40 hours a week. I think I make I think I'm on $5.50 an hour, something like that. I don't know. I make about $1 a day after taxes and all that good stuff. But the hourly rate here on this paycheck is $16.75. Work for 40 hours and you get $670 total. Take a look here at this paycheck. I'm going to kind of zoom in on this area. Let's talk about gross pay. That $670 is the total amount of money that you made. Now the net pay is the money that's left over after the deductions, after, in this case, the taxes are taken out. Gross and net. Gross is the total amount. Net is what's left over after something happens, like taxes. So gross primary productivity, or GPP, and net primary productivity, NPP. It's an equation. The net primary productivity is equal to gross primary productivity minus those deductions, and our deduction is going to be respiration, right? Plants are not making the food for us or for the primary consumers or anybody else, anything else in a food web. The plants are making the food for themselves. It's just that they make so much of it that we're able to utilize some of it as our own food. Respiration is the reason why NPP is always smaller than GPP. There's only about 40% of the energy is left over after respiration. That means 60% in a plant, about 60% of the sugars that it creates is going to be used for its own processes of respiration itself, leaving 40% left over. It's still quite a bit left over. The productivity can be measured in kilograms of carbon per square meter per day. It's just a crazy looking unit. kgc over m squared over day. Sometimes you see it per year. Okay, so NPP, net primary productivity, is really biomass, and biomass is the total amount of living material in a specific area in an ecosystem. Biomass is, the term is used quite a bit in AP environmental science. In fact, sometimes it's used to refer to like firewood, for example, firewood that might be used to heat a home in a developing country, or might be used to cook food for folks that don't have a stove. So biomass refers to, again, really the plant source and any carbon in a specific area. Take a look at the net primary productivity all over the world here. In the previous video, we talked about how along the equator we find those rainforests. And take a look, rainforests are pretty productive. If we look at this key here, quite a bit of carbon being produced along the equator. The high productivity in this area is because there's high amounts of water, there's a lot of nutrients, there's warmer temperatures, and all of these conditions are more favorable to the plants. And so if you have great conditions for plants, you're going to make a lot of plants, or plants are going to make a lot of food rather. And if you remember that above the equator at 30 degrees north or 30 degrees south latitude is where we find Las Vegas, or deserts usually. Deserts don't have as much water, so the producers don't grow as well. As a result of deserts, productivity is lower compared to other types of ecosystems. This is called a trophic pyramid, and the trophic pyramid is usually used to describe the amount of energy that is transferred from the producer level upwards to the primary consumers and to the secondary consumers. About 5 to 20% of that energy is passed from one trophic level to the next. You might be thinking, where'd the rest of it go? It's lost to respiration as heat, and as heat as the organisms use up that food. 5 to 20% pass. The numbers, though, on our trophic pyramid look like about 10%. So you'll see this number quite a bit. Around 10% of the energy is passed along at each level. The rest of it, 90%, is lost as heat to respiration. What if we took this trophic level out and we put in some organisms that we might eat? Take a look. Cows eat the producers, wheat we'll say, and we in turn eat the cows. We can live more sustainably on this earth if we kind of eliminated the middleman, right? If we eat closer to the producers, right, and just got rid of, maybe became a vegetarian, got rid of, in this case, the cows, think about how much more energy we have available to us. 10,000 joules of energy total versus just 1,000 joules if we're eating directly from the cow. Think about what we can do to live more sustainably in this class. That's what this class is all about. Hey, after this video, make sure that you can describe energy flow in a food chain, calculate NPP, explain why NPP is 40% efficient. It's because of respiration that the plants undergo. 60% of their food is used as respiration, 40% is what's left over. And then explain why only about 10% of energy on average is transferred between the different levels. Thanks for watching.